Hello, everyone. Welcome to the Sharding P2P Roundtable session. And this session is going to discuss about the Sharding P2P requirements and the implementation, and hopefully we can settle down to a single implementation and start working on it. So the agenda. First, I'm Kevin from Ethereum, and I will introduce the Sharding P2P requirements and the current idea first. And then Lars from Protocol Labs, he will talk about the P2P and Gossipsub. And then after that, we will have a roundtable discussion. So about Sharding P2P clients requirements. The first one, we need a client should be able to subscribe to multiple shards. And it should be able to jump between shards really fast. And so it also means that the clients should be able to find nodes in other shards in a short time. So one of the option we're considering to use is pubsub. So the pubsub, about pubsub, it is basically a way for subscriber to subscribe to certain topic, and publisher can publish some data to that topic, and subscriber will only receive the data of the topic they subscribe to. So in the pubsub system, it needs an overlay network underlying, and for each topic, there will be a channel on top of the pubsub. So the reason why we are considering to use pubsub is you can imagine that the shards can be mapped to topics. So a client can choose to subscribe to a certain shards, and it will only receive the data from its interesting or its listening shards. And the current implementation for pubsub is there is one available in the P2P, and it is called pubsub, and it is the first version of the pubsub in the P2P. And its implementation is Go and JS and Rust, and its idea is the node, when it receives or publishing data, it just flow messages to all of its peers. And then the Gossipsub comes out, and it is still in the pull request in the P2P repository. And the spec is also available. And its idea is for each topic, a node maintains a certain number of peers to gossip and relays the messages only to those peers. So, and its strategy is, there are two strategies. The first one is eager push. Eager push means that it just sends the whole data to a specific peer. And lazy push means that it just sends the summary of the data. And usually it is a hash of the data. So in this graph, you can see the black arrow, and this is the eager push. So the node just pushed the data entirely. And for other nodes, for these two nodes, the link the node just pushed the summary of the data. So it is the lazy push. Sorry. So after a node pushed a summary to other nodes, if other nodes like this node, after a period, if it doesn't receive the corresponding body to the summary, it will find that it lacks of some data. So it will ask for the original node which sent the data to it. So it will get the data. So it is called lazy push. And Gossipsub use both of them, both of the strategies. And these two strategies make Gossipsub more efficient. I mean, because in FlowSub, you just broadcast all of the messages, and there will be a lot of redundancy, and Gossipsub can reduce this redundancy. And Gossipsub has further optimizations. The first one is broadcast tree, and its idea is in Gossipsub, we still need to broadcast broadcast a message to multiple peers, but it still has redundancy. So if we construct if we embed a broadcast tree into the Gossip protocol, we can the message will only be broadcast once across the peers. So it largely reduced the redundancy. And the second one is it introduced the membership management protocol. So the idea of it is it allows peers to exchange their part of their partial view. I mean, they can exchange their peers' information, and that makes the whole network more reliable. And the proximity awareness. So this optimization allows requires the peers to keep track of its peers' latency. So if a node's latency is too high, it will be replaced by the nodes with lower latency. And the pros and cons, it is a summary from me. So in my opinion, the pros of using Gossipsub as the P2P layer will be it reduce the development effort for us because we will no longer need to consider to solve the complexity of maintaining so many shards simultaneously, and it is also supported by the P2P team, and it possibly be used by Filecoin. And the cons might be because some of the features are not yet implemented, like the authentication and the encryption. So for now, they are not implemented, and other features. So yeah, and another one is it only supports Golang and JavaScript. So for us, like sharding implementation in research team, we use Python. So we need to write bindings to use that. And the current idea for us, for sharding P2P. So our idea is we're using pubsub to do gossiping, and we will have global and local gossip channels. So the global means that it is subscribed by every node, and the local means that it might be a shard, so some of the nodes can subscribe that, but while others not. So we use the global gossip channels to broadcast the shard subscription preference. So every node will broadcast its currently interested shards. So everyone will know which peer is listening to which shard. And also we use the global gossip channels to broadcast the main chain and beacon chain messages. And the local gossip channels is the shard-specific informations. And about the peer discovery, we use boot nodes, and besides we use the global channel I just mentioned, and So every node will broadcast their currently subscripted shards. In this case, every node can construct a shard preference table. Yeah. And when they are going to join a specific shard, they can just use this table to find the corresponding peers. And we also provide the API for each node. And for this API, a request shard preference table. So if a node it just joined the network, it will not have the information about the table. So it can ask this information from its peers. And also the request correlation can be used to synchronize the whole shard chains. And ongoing works. And we're currently researching on Gossipsub and keep testing Gossipsub. And for now, we're testing in a smaller scale and mainly focusing on the performance, but haven't tested like the reliability and others. So we'll keep doing that. And I will keep finishing the POC of the Sharding P2P idea we just mentioned. And I have a preliminary version, but it is incomplete for now. And after we build this POC, we can write the Python bindings to make the Python side to call this the P2P layer, so that we can do more tests. Yeah, and that's it. Any questions? Okay. You have my slides? Yes. Awesome.
Thank you. Yeah, thanks for having me. My name is Lars, and I work on the P2P team. I live here in Berlin, so I feel right at home. I'll be just giving a bit of context of the P2P real quick. So when we started building IPFS, we noticed that everybody's reinventing the same stuff over and over again, just because, well, distributed networking, or decentralized networking, never really dominated anything, so nothing got into any kernels or anything like that. So there's the P2P wheel, the cross-platform wheel, the upgradability wheel, and so we started the P2P project, which is a modular P2P networking stack. There's currently 3 usable implementations. The Go implementation, which was extracted from Go IPFS, the JavaScript implementation, which was largely a greenfield project and runs both on servers and in the browser. And the youngest one is the Rustlet P2P implementation built for Polkadot by the fine parity people. And more implementations are welcome, of course. So users are IPFS and definitely Filecoin, LivePeer, who are running the stream. Am I live right now? Awesome, thank you. Polkadot, obviously, OpenBazaar, MetaMask, MediaChain in the past, and a lot more that I forgot to put on there. The P2P is basically just a bunch of components. Each of these components is just basically an interface, just a couple of methods, just a couple of functions that implementations implement. There's transports, crypto channels, well, pubsub, as we already heard, discovery for just finding any nodes, peer routing for finding addresses for specific nodes, content routing for finding nodes that have specific content. There's stream muxing to put multiple streams into, well, one stream. And there's relays. And by the way, the ones that are in italics here are currently works in progress. So the project roadmap is, well, libp2p just this year became a first-class project of its own. So we're still doing a lot, bootstrapping that project with dedicated plannings and RFPs and RFCs and meetings. We are going to increase the work that's put into testing, into simulations and benchmarks, interoperability testing between all those different implementations. We're going to work a lot more on documentation, which is, you didn't put it on the list of cons, but it clearly is one right now, which we're aware of. And one question that keeps coming up is the one about security audits. And we already are doing a couple of them. And we're taking this approach of having individual components of libp2p audited, and we're starting from the bottom up, so to increase the strength of the foundation going up, so to speak. And the short-term feature roadmap is definitely, well, Gossipsub, because we need it for Filecoin, other projects need it as well, and we're pretty close to having a first version usable. There's a spec, there's a Go pull request, as Kevin already mentioned. And there's going to be a lot more work put into simulation, into improving it, to its security, hardening it against attacks. And about more implementations that you mentioned, like using Python and all that, we want to have a daemon, a libp2p daemon similar to the IPFS daemon, which you can run and it exposes an API. And then you can have bindings in various languages to control that libp2p daemon, to bind your own protocols in different languages to it. And that's, I think it's going to help a lot. It's going to help me personally a lot. So just, yeah. And we want to improve connectivity a lot. The TCP transport currently is pretty heavy on resources and on little home routers, because it turns out 600, 700 connections just simply killed some routers. And then there's smaller changes for DHT performance and little migrations away from RSA key pairs, for example, which are really CPU intensive to generate, while ED keys are simply random data. And yeah, you already went over some of pubsub. Yeah, flatsub was the very first naive implementation of the pubsub interface. Just simply flooded everybody. And Gossipsub is meant to be a bit smarter, a building block for more advanced pubsub protocols as well. And yeah, gonna put a lot more work into that going forward. There's been a pretty interesting discussion of those Ethereum requirements you were mentioning, the sharding requirements in that GitHub issue up there. And yeah, there's spec documents, there's a simulator that you can try out. Yeah, and one point that's pretty dear to me, and that's the last slide, is that if you pick libp2p as a foundation for your application, and you make it run on the general public libp2p network, you gain with every node of another project that joins the network, you gain connectivity advantages. The DHT is strengthened not just by Ethereum nodes, for example, but by all nodes out there that use libp2p. You get connectivity in web browsers for free, net busting, all that. You get privacy-enhancing transports for free. So OpenBazaar have had a lot of success with an onion transport in libp2p, which we're having audited and included into libp2p. And in the not too distant future, like end of this year, beginning of next year, we want to do like properly routed packet switched overlay networks on libp2p, so that when you want to communicate with a different node, you don't actually have to directly connect to it, but you send stuff over the overlay. And once we have that feature, then the first point that every node of other applications strengthens the network really starts to pay out. And yeah, so much for the context. Thank you.
So may I invite Felix and Lars? Yeah. And I prepared some questions, and I'm wondering if you guys have some questions already. Yeah.
Thank you. So I had two questions. So first of all, when you talk about pubsub model, where I guess there's subscriptions, who is actually keeping those subscriptions, and what about, can they disappear? And the second question is that in none of the, I'm sure there is something, but in none of the presentations there was any mention of the adversarial environment and how we deal with those.
Okay. From the subscription, when you join, first you have to join the overlay network, and after you join, when you subscribe to a, when you sorry, when you do subscribe, you will broadcast. Sorry, you will send the message, a subscription message to your peers, and your peers will know the subscription status of you. Yeah. So every node will keep its peers' subscription. And about the second question.
Yeah, about the adversarial model. Reason it's not up there is I didn't work on Gossipsub myself yet, and didn't have too much time for preparation. Anyway, there is documentation and discussion about it. I couldn't find it in the short time, and I'm gonna get it for you and put it in the documentation of this day, I guess, of the agenda. Yeah, I just don't have a good reply for it right now.
I mean, to be more specific, is that I don't think that we can build this peer-to-peer protocols are completely isolated from the network they're going to be operating. For example, you want the peers to actually filter out the messages without relaying them blindly. So you can't relay messages blindly because they could be the spamming of the network. They have to apply some kind of rules, and these rules will inevitably be the network specific.
Yeah.
So that's what an adversarial thing I had in mind.
Yeah. So in general, these epidemic protocols, like the pubsub approach, are sort of more resilient than, say, like a routed solution. So that's definitely something to keep in mind. So it's kind of hard to break like an unrouted network like the one that he just presented. But with the spam issue, there's always this thing that, like, in the end, I think the way to see this now, this effort, is to say that, you know, like the sharding prototype, the actual prototype, it doesn't really matter what it runs on. So it can run on like any sort of insecure protocol as long as it's efficient enough to support a couple thousand nodes or a couple hundred nodes, and there will definitely not be a lot of value in the system initially. But then over time, as the proof of concept gets more mature and, you know, more value is being put in the system, then there will definitely be, like, my guess is that it will just evolve into some kind of custom protocol that has these checks built in. So I don't think that the Ethereum sharding will run on like a generic pubsub protocol forever.
libp2p sounds really awesome. I'm just wondering if you guys considered any other P2P systems or libraries for sharding, and sort of why did you settle on libp2p? What makes it especially well suited for this application?
Okay. We did survey the dev P2P or use lib P2P directly before. But in that case, you have to maintain like the peer discovery. If you separate the network for each shard, then how do you do network peer discovery? You might rely on the boot nodes, right? For each shard, you will need some certain number of the boot nodes. But so you, in that case, you will entirely rely on the boot nodes. So unless you use other kinds of the topology, like Yannick, he previously proposed a torus network topology. So in that case, you can ask your peers about like, do you know any peers in specific shard? So you will know that for when in the torus topology, you will know you will ask the next shard peers, and you will. So I mean, you need some certain way to find the peers in other shards. In that case, so it is, for me, it is more difficult. I mean, for now, if we just use pubsub, it can solve this problem. Yeah.
I have a very basic question. Can nodes running libp2p talk to nodes running dev P2P?
Maybe like for me the question. So no, not yet. So there's definitely an effort underway to make it possible to share transport implementations, at least with the P2P project. So the idea would be that in the long future, even Ethereum 1.0 will have the P2P transport option. And in that case, it might be possible to, for example, download information about mainnet blocks on Ethereum 1.0 using the P2P. But that's not possible right now. So right now, all the implementations of Ethereum basically run the custom protocol they always ran, and it's just, yeah. And there's no like, no connectivity option. But I have a comment for your earlier question as well. So there is like another system that's like within reach, and that could totally be tried. And that system is PSS. So you all heard about it on the first day. The Swarm team just released it as part of their POC 3, and it's available in the Go Ethereum repository. It also comes with like a standalone daemon and everything, so it's kind of comparable to the P2P daemon in the end. So basically, there's a daemon, you can connect to it, you can talk to its API, and send messages through a routed overlay. And I guess it's kind of funny that like these things like sort of like, you know, we kind of have like the same stuff. So, but it's like yeah. So this like even in the like. In another corner of the Ethereum ecosystem, you have like another system that could be tried, and I think these that could be like an interesting experiment someday to just check, you know, like let's just run like the PSS daemon and see how that performs. It does come with it has a bit of a different like privacy trade-off, so that can be considered, but it does have on the other hand it does have encryption, which isn't really built into pubsub or Gossipsub at the moment, but I guess you can just always layer that on later. So it's just, there's definitely like alternatives, but there aren't that many alternatives. That's the thing. So basically, when you're building a system like that, like the sharding prototype, you always have to choose. You have to either you choose like some library, you make your own protocol, or you use one of the things that already exist and somehow adapt them. And I think the P2P right now is really the best choice because it gives you it's like a very modular toolkit. You can pick all the different trade-offs you want. It gives you a lot of stuff for free. So I think it's kind of the ideal candidate for the state that the project is in right now.
any question?
I probably don't have a full picture of lib P2P environment, but it seems to me quite limiting to encourage have much more implementation, like for every programming language have another implementation for lib P2P. Have you thought about having some kind of inter-process communication for network stack to have some kind of daemon running in the system and then just communicate locally with this process from, it would be much easier to implement for like Python, for example, except like implement all of these protocols you currently have for new languages.
Yeah, absolutely. Definitely. Yeah.
But is there any
any
progress about that?
There's a bit of initial design for the daemon, and I'd like, for the first version of the P2P daemon, I'd just like to largely take the model that the IPFS daemon uses. But there's a lot more work, or a lot more down the road for that daemon after the first version, which is hopefully gonna be worked on soon. So we have this developer meeting in 2 weeks where we're gonna decide on the roadmap for the next half a year, and I'm gonna push for a daemon very hard. But anyway, after that first version of a daemon, which will be very simple and where the main goal will simply be for other applications and other languages to just be able to speak to an API and use the network through the API. After that, there's gonna be probably a Unix socket API to that daemon just for better performance, because HTTP is, well, can be limiting. And then there's even more options. There's the option of pushing the lower levels of libp2p into the Linux kernel, for example, the crypto channels and some of the transports. Then the last future point up there was a routed, a packet switch routed overlay, and some part of that could also be pushed into the Linux kernel. So there's, for example, regarding crypto channels, there's this very interesting new VPN project called WireGuard, which is a kernel module. And thanks to it being a kernel module, its performance is just stellar. You can get 1 gigabit per second of throughput on the tiniest VPS you can get for $1 at any hoster. And so we'd like to use that as a crypto channel in kernel land, for example, but that's way down the road, sometime next year.
Okay, so final comment. How can we actually like participate in these discussions about that? It's like where should be the first point I should like visit and check actually this particular subject?
Yeah, definitely. So all discussions and documents and all that is on GitHub. So there's the libp2p/libp2p repo for more general discussion that's not specific to one specific implementation. And then there's the libp2p/specs repo and the 3 repositories for the 3 implementations. So libp2p/go-libp2p/js-libp2p/rust-libp2p. And there's also in 2 weeks these developer meetings on the, wait, what day is it going to be? Yeah, it's going to be Thursday and Friday in 1.5 weeks. So I'm not 100% sure who from the Ethereum community applied to come there, but if you haven't yet, obviously. If you haven't yet and you're really interested in like libp2p development and planning, then send an email to, oh gosh, well, I guess to me, and I'm gonna relay it.
Has any work been done on mobile? Like, does this work on mobile? If not, what would need to be done to make it work on mobile?
Yeah, it does, certainly. There's an experimental prototype-ish Android app called IPFS Droid, and it runs, well, Go IPFS on mobile, but it's not optimized for mobile use cases yet, so it can't pause or resume connections. It just keeps running and, of course, keeps eating your battery because the cameras are constantly on, the CPU is constantly on. There's a couple of more optimizations which have already been done. For example, the DHT client mode, where you don't act as a server, so to speak, in the DHT, but only make requests. But that's just a tiny step. And being able to suspend and resume connections or the whole daemon is pretty critical for mobile.
So actually, I just so the reason why we have Guillaume here is because your earlier question was also that if there's like any way for libp2p to talk to dev P2P systems. So one thing that we're doing right now is that we're porting like yet another part of the Ethereum ecosystem, which is the Whisper protocol, which is also surprise a pubsub protocol to libp2p at the moment. So that's also something that's going on. There's actually something where, as far as I know, Parity is also participating in that effort. So I guess we'll have a lot of options. Yeah.
Yeah, I mean, okay. So Whisper is supposed to be a messaging system. Well, the definition can vary depending on who you ask, but yes, the goal is to ensure darkness. So when you send a message to someone else, an external observer should not know if you're sending a message, who you're sending it to, and of course what you're writing. So yeah, we have this PR that's currently open. About implementing. No, that was not a remark. No need to. No need to sneer. Oh, that was you. Okay. Yeah. So we have this PR, and indeed, like we just we add a new like we use libp2p like the protocol streaming. Sorry, the multiplexing to send dev P2P packets over IPFS. Yeah, so like the reason why we did that in the first place was because we wanted to see if we could build. Okay, because Whisper uses Gossip, so it's really heavy on the network. I think there was a gentleman saying earlier, how do you filter messages? Well, in Whisper you don't. You just send everybody your messages to everybody. So a lot of nodes are not activating Whisper because that's a lot of processing time that they spend just decrypting messages that are completely that are not intended for them. So yeah, we wanted to see if we could build our own network with only parties interested in Whisper. And yeah, so that's also being used for prototyping, because if we can, I mean, maybe that's a bit controversial to say that, but if we can chuck dev P2P altogether, that will save us some maintenance time as well.
I actually have a question. If we set, sorry, hello. Oh. If we settle down to use Gossipsub as the P2P layer, do you have any idea of building the testnet? Because I have some thoughts in mind that I think if we settle down, we can make a spec, and it is cross languages. So we just regulate the messages and the protocols, and we can in different implementation of the Gossip clients, we can build the testnet together. I mean, from the Python side, we can also use the Python bindings to call. Right, we just write some code in Golang and write the bindings to call from the Python, and we also can do the testnet. So, is there anyone has any thoughts on this? And about I also have some questions, especially to Lars. I'm just wondering how will the Gossipsub be used in Filecoin, possibly?
Well, it will be used, certainly. That's one of the huge priorities that the Filecoin team have brought to us as the P2P team. Get us good pubsub, and Gossipsub is the first step to that. How exactly they're using it, I actually have no idea. There's just so much stuff to follow in IPFS and P2P that I don't find the time to also follow Filecoin. So sorry about that. But I can get an answer to that and add it to the documentation of the day.
Thank you. And any questions?
Is that broadcast tree a part of a Gossipsub spec or spec somewhere else?
Yes.
Okay.
Yeah, it's in the Gossipsub spec.
Also, I'm wondering if there is a plan for the testnet of Gossipsub. Yeah. And what will it be? I mean, the plan. Do you have any idea?
Yeah, I mean, we'd like to get good, automated, continuous test beds like yesterday. Because not just for pubsub, I mean, for all the rest of the P2P, for IPFS, for Filecoin, we just need good test nets and simulations and benchmarks. And yeah, it's going to be really high priority in the rest of this year. Just because you can't build huge, large-scale distributed networks without any of that, right?
And about the features, like the okay. And I just come up with one question about the attacks on the Gossipsub, because previously I already have in mind like you can just send the data which is not subscribed by the peers, so you just send it and like you can just occupy its bandwidth. And about this, is there possible to have built-in prevention or protection mechanism, or plan on any prevention of the attacks?
Not yet, really. I mean, on that particular attack, you can DDoS, or you can exhaust the network resources of pretty much any network servers, right? That's not something that Gossipsub alone can prevent. All it can do is flag sources of traffic for an external tool to pick them up. But Gossipsub is an application layer protocol, so it can't drop packets on layer 3, for example. And even if it could, they already would be at the host and the network. If the traffic is already at that point, then it's already not exactly too late, but if you want to prevent any network exhaustion attacks, you need to do it somewhere at the boundary of your own network, like at a firewall, at a router, at a switch. But yeah, attacks and DDoS attacks specifically, or other exhaustion attacks, And also attacks in general on Gossipsub, I don't have a good reply for you. I know. Yeah, go for it.
So the question would more be on that note. So you said that like maybe you could flag like the sources of traffic. So that would be definitely an interesting discussion, how to build a system like that that allows you to sort of like also stay a bit anonymous, because one of the worries that we have for the sharding network specifically is there's like certain classes of actors in the sharding network that are very prone to DOS. For example, like if you're a POS validator, for example, you don't really want to be DOSed because you're going to lose money over that. So this is kind of important to stay anonymous. And then my question would be, if there's like specifically like in Flutsub, well, in Flutsub maybe not, but like in Gossipsub, there's like any, or in the underlying protocols, there's like any prevention of like, you know, your actual IP leaking out or something. So it's not so much about, you know, DOSing a node within the protocol, but more like figuring out what is the node's actual IP on the internet, and then just like DOSing that. Because that could be catastrophic for a system like proof of stake, where specific machines need to be online at a certain time of day to actually do something, and otherwise they lose money.
Yeah, privacy enhancing transport, most of all. So the onion transport comes to mind as the very first thing. Obviously, Tor, not high throughput, not low latency. But the onion transport is Tor-based, yeah, exactly. So on the one hand, you can dial through Tor relays, and on the other hand, you can actually listen on make your P2P node listen as a Tor hidden service, and possibly more to come, but that's the one that's tangible right now.
Yeah, so if anyone's interested in doing like cool research, that would be like really cool research to have like sort of like, because like especially with something like Tor. So I'm guessing like a lot of people in the room have used Tor or like tried it or read something about it. It's kind of a famous project or anything, but it's like Tor is always this thing that's not really like, you can't just really plug it into your application. It's like a service that you can use. You can tunnel your traffic through it, but the actual techniques behind Tor is like something that it would be really useful in a lot of protocols. So if someone had like something where you could just like make that pluggable, that would be great.
Yeah, just a quick addition to that. There's actually now a pretty young but really useful Go library that embeds Tor right into your binary, and so you don't have to run the Tor service separately. It's pretty young, not audited, but super useful.
Yeah, okay, so now then you can like import Tor, but it doesn't really. Yeah. So yeah, that's cool and all, but like there's no like, this is I think something that could be really cool to have in libp2p as well, would be to have like a native, so like a libp2p native onion routing thing, because it's something that is useful in a lot of cases. Yeah.
So probably well before that, there's this layer in GNU-net that I think you guys still don't have. It's called Cadet, which it handles routing between hops. I think you guys only route like through one, like you do have an indirection capability, but it's only one hop or something. Anyway, but you probably, something like that even before, and there can be some weird layering things to think about there. Anyway, another time.
Okay. So, anything else, or is that it? Oh, there's you. Yeah.
Okay, last question.
So you mentioned in your presentation of libp2p that there's a benefit of having more participants in the network, and I don't quite understand why. Like, why is it? Do they all participate in some kind of the global network, or is it? And how does it work? Because if you do, like, you're not really peered with the network you want to be peered, but are you peered with so many? Like, what is the number of peers in the P2P?
So it's, I can answer it too. So it's like basically when if you participate in the DHT, for example, to use its services, then basically everyone else who is also using the DHT in their project is also in that very same DHT. So in that case, you're not really like peering, as in like directly talking to these nodes about your application, but it's more like certain basic, like certain base layer services are just used by everyone.
And one more feature that doesn't play out yet because it's not there yet is well, this routed packet switched overlay. And the advantage there is basically the same idea, just a layer lower on the connectivity layer. That there's certain base services / building blocks that are shared by everybody, and that gets, well, they get more throughput, more bandwidth, or more resilience if there's more nodes. For example, if a packet-based P2P overlay in 1.5 years, for example, has 1 million nodes on the world, or 10 million, or in the best case, then it's much more likely that you have that you're going to find peers that are, on the one hand, physically pretty close to you, or otherwise well located in the network for your purposes, than if the network is really small and only focused on your own application. And the idea with that routed overlay is definitely to cover as much of the networked world in the long term, and also try and transport IP traffic over it, have it peer with the existing internet infrastructure over BGP, and yeah. One more addition, because you were saying a native anonymity layer in libp would be nice. That's also something you can layer on top of such a packet switching overlay building block, so to speak. And then the bigger your network gets, the more advantageous it is to your anonymity purposes.
Just a last quick question. Yeah, you said you wanted to start embedding the libp2p, well, Daemon, whatever, into the Linux kernel. So, I used to be a kernel dev. Linus Torvald has said like his main job was to say no to stuff. And like the way I see is, this is a library that can be used on other operating systems like FreeBSD. Like, if you start embedding that, like, what would be the purpose? What would be the advantage of doing this thing?
Yeah, maybe to clarify, we probably wouldn't put the whole daemon into the kernel, but just the lowest layers of it, like a UDP transport, a TCP transport, the very simple basic transports, and probably reuse WireGuard's crypto channels. And then later, once the packet switched overlay is there, probably also the packet switch, just for performance reason. You don't need to copy packets between kernel and user space. It's much easier to have dedicated hardware for it, FPGAs, for example. And yeah, and one goal apart from performance is obviously like not just performance, but performance on commodity hardware. What about FreeBSD? I haven't thought about it yet, but fuck it, why not? Yeah.
So they do have like a kernel module system. So you, like just like Linux, you can just you can load your own modules and stuff. You have that on Windows too, so you can. Okay, I guess that's it.